close your eyes. Strip away the warmth of the sun. Silence the noise of Earth. Forget everything you know about distance. We are going to the edge. There is a world sitting in the profound darkness of our own solar system. It is a place so frozen, so terribly lonely, that even with all our proud modern technology, no human being has ever stood upon its surface. And here is the truth that few astronomers say out loud. No one ever will. Not in our lifetime. Perhaps not ever. We are talking about Pluto, the exile, the forgotten king. It rests over 6 billion kilometers away, a distance so vast it turns our fastest rockets into crawling insects. To understand this abyss, you must realize that in the entire history of our species, only one machine has ever managed to reach it. New Horizons, July 14, 2015. And even after 9 years of screaming across the void at unimaginable speeds, it couldn't stop. It didn't orbit. It didn't land. It was a bullet fired through a ghost. It caught a fleeting glimpse, a handful of photographs snapped in a frantic rush, and then it continued its eternal fall into the blackness beyond. Why? Why invest billions of dollars, decades of human genius, only for a brief agonizing flyby? Because Pluto does not want to be found. The primary reason we cannot truly reach Pluto is a cruel paradox of physics. It is a cosmic trap built on a single, unforgiving variable, speed. To cross 6 billion kilometers before the scientists who built the probe die of old age, you need velocity that defies comprehension. You must construct the fastest machines ever made. New Horizons was launched in 2006 like a cannon shot. It passed the orbit of our moon in just 9 hours. It took the Apollo astronauts 3 full days to do the same. It was moving so incredibly fast that it crossed the entire solar system in just 9 years. But this speed is a double-edged sword. When you arrive at your destination, traveling at 50,000 kilometers per hour, you cannot just hit the brakes. In space, there is no air to drag against, no friction to slow you down. To enter orbit around Pluto, to actually stay there and explore, that speeding bullet would need to suddenly reverse its momentum. It would need to fire massive retro rockets straight ahead, burning an unimaginable amount of fuel to fight its own velocity. And that is the trap. To carry that much fuel, the spacecraft becomes too heavy to launch. If you make it light enough to launch fast, it cannot carry the fuel to stop. We are trapped by our own technology. We can get there fast, or we can get there slow. But we cannot stop when we arrive. And yet, decades ago, we almost had a chance. A window opened in the mechanics of the heavens that could have changed everything. For most of history, Pluto was just a vague dot on the frozen frontier. The 9th planet. The end of the line. Whatever was out there, we assumed, would have to wait centuries for a visitor. But in 1964, an engineer at NASA's Jet Propulsion Laboratory named Gary Flandreau noticed something hidden in the math. He realized that the giant planets, Jupiter, Saturn, Uranus, Neptune, were drifting into a rare cosmic alignment, a grand arrangement that only occurs once every 176 years. It was a golden path. A single probe, launched at the precise moment, could use the immense gravity of each giant planet as a slingshot. Jumping from Jupiter to Saturn, gaining speed without burning fuel, all the way out to the edge, NASA proposed the Grand Tour. 2 twin probes that would ride this gravity wave all the way to Pluto by the mid-1980s. It was ambitious, it was beautiful, and it was canceled. The cost was too high, the vision too grand for the budgets of the time. Instead, we got the Voyager probes. Magnificent machines, yes. Voyager 1 actually had the option, after visiting Saturn, to set a course for Pluto. The door was open, but the mission planners made a choice. They sacrificed Pluto to steer Voyager toward Saturn's largest moon, Titan. A scientifically valid decision, but a heartbreaking one. Pluto was labeled small, distant, and unnecessary. Why spend billions on a dwarf rock when the gas giants offered so much glory? It was dismissed as a frozen mistake at the edge of the sun's domain. Too far, too dark, too risky. They didn't even use solar panels on those early deep space probes. The sun is just a bright star out there. They used nuclear batteries, praying the heat of radioactive decay would last long enough in the crushing cold. Going to Pluto wasn't just hard, it was seen as a fool's errand. If sending a robot is this difficult, sending a human being is fundamentally impossible. The challenge shifts from engineering to sheer biological survival. We are fragile creatures, evolved for the thick atmosphere and gentle gravity of Earth. We were not meant for the void. A manned mission to Pluto, using our current chemical rockets, would not take 9 years. It would likely take 15, perhaps 20. Just to arrive, imagine sitting in a metal can, smaller than a prison cell, for 2 decades. A round trip would consume an entire adult human life. In a world where technology revolutionizes every 5 years, you would launch in a state-of-the-art vessel and arrive 20 years later in an obsolete antique. The logistics are nightmare fuel. You would need millions of liters of water, air, and food. You would need life support systems that cannot fail for 40 years. And then there is the invisible killer, radiation. Once you leave the protective magnetic bubble of Earth, space is flooded with lethal cosmic rays. Over a 20-year voyage, the crew's DNA would be slowly shredded. Their minds would buckle under the extreme psychological isolation, further from home than any human has ever dreamed of being. It is a suicide mission. Today, manned missions to Pluto are not science fiction. They are fantasy. Which brings us back to the only way we have ever touched that world, the desperate high-speed gamble of New Horizons. When New Horizons finally approached Pluto in the summer of 2015, the tension was suffocating. The entire mission hung on a razor's edge. After traveling billions of kilometers, the probe had to hit a target window just a few hundred kilometers wide. A microscopic deviation, a breath of error, and it would miss the planet entirely. And the most terrifying part? NASA was flying blind. At that distance, radio signals take over 4 hours to reach Earth, and another 4 hours for a command to go back, an 8-hour round trip. By the time Mission Control saw an image of Pluto, the probe was already past it. If something went wrong during the encounter, there was zero chance to fix it. It was like driving a race car blindfolded, relying only on instructions you memorized 9 years ago. The probe went silent for the critical 24 hours of the flyby, pointing its antenna away from Earth to focus its cameras on the planet. On Earth, the scientists just had to wait and hope. When the signal finally returned, bringing the data with it, the images stunned the world. We expected a dead cratered ice ball, a dull frozen relic of the early solar system. Instead, Pluto showed us a living face. We saw mountains of solid water ice towering as high as the Alps. We saw vast, smooth plains of frozen nitrogen that showed signs of recent geological activity. A world that was churning, breathing, active. It had a massive heart-shaped formation etched onto its side, become an instant icon. Pluto stepped out of the cosmic anonymity and demanded our respect. It taught us that even in the deepest freeze of the furthest reaches, the universe holds astonishing surprises. And yet, the triumph is bittersweet. New Horizons collected what it could in a few precious hours and then rushed past, sailing onward into the Kuiper Belt. It could not stay. Its incredible speed, its greatest asset, was also its greatest limitation. Even today, years later, that brave little robot is still slowly trickling data back to us across the immense divide. The difficulty of reaching Pluto raises profound questions about our place in the universe. We are bound by the tyranny of distance and the brevity of our lives. There are doors in this solar system that are locked to us, perhaps forever. Some scientists dream of nuclear engines or giant solar sails that could one day slow a probe down, allowing it to orbit that mysterious world. But these are dreams on drafting tables. For now, Pluto remains what it has always been, a distant seduction, a reminder that scientific labels like dwarf planet mean nothing to a real world with jagged mountains and deep valleys hiding in the dark. It represents the boundary between the known and the unknowable. Whatever the official charts say, in the human heart, Pluto will always be the ninth planet, the one that got away,